A private pilot flies a Cessna 172 on a trip that is 500 miles each way. It takes her 3 hours to get there and 4 hours to return. What is the approximate airspeed of the Cessna, and what is the approximate wind speed? So when we're talking about the airspeed of the Cessna, what we mean is the speed of the plane in still air. So if there was no wind, how fast would the plane be traveling? And you can see that it takes her less time to get there and more time on the way back. And that's a result of having a tailwind, a wind coming behind you that's pushing you faster, and also then turning around and having a headwind, wind where you're flying into the wind, so it's slowing you down. So this is what I would call a standard distance equals rate times time problem, because we're looking at how fast the plane's moving, how fast the wind's moving, and those are rates. Those are what we would call R values. So I would go ahead and set this up using our distance equals rate times time formula, otherwise known as DIRT, if you like that. And so if a grid works for you, a lot of students find that getting organized on these problems is helpful in a grid format, because you can see, okay, I have these three quantities: the distance traveled, the rate, how fast I'm traveling, and the time. And then I'm comparing it, the distance, rate, and time in two different scenarios. For this instance, it's the plane going to the destination and then turning around and coming back. So I'll just mark this as the plane's going to the destination. If it'll let me do that. Okay, I'll go to and back. All right, so let's see if we can start filling in some of the blanks. So start with the D, the distance. How far is it to get there, wherever this pilot's flying? And it says that the trip is 500 miles each way. So getting there, going to the destination, is 500 miles, as well as the return trip coming back. Both are 500 miles. Now let's look at the rates. I don't know how fast the plane is actually traveling on the way there. And that's because if you envision your little plane here, there's my little plane. The plane, let's say, is traveling this direction. The wind has an impact on how fast the plane is actually traveling. So let me put in some fictitious numbers for you to help you understand this idea. So let's just say your plane was traveling 100 miles an hour. And let's say we had a 20-mile-an-hour wind. So if you were in the situation where you had a tailwind, then the wind would be coming here from behind the plane, pushing the plane. So the impact, of course, is that the plane is going to be traveling faster. So if the wind was 20 miles an hour, but it's coming from behind, a tailwind pushing the plane faster, then the actual speed of the plane would be 120 miles an hour. Whereas in the reverse situation, if my plane is traveling 100 miles an hour, but this time I have a headwind, so I'm working against the wind, so my wind's coming in this direction, what's happening is it's going to be slowing me down. So if it's slowing me down, I will not be able to really travel the 100 miles an hour. Then in this scenario, I would be traveling 80 miles an hour. So you can see that we take our speed, the plane's speed, and we add the wind speed if we're moving faster, and we're going to subtract the wind speed if we're moving slower. So my unknowns right now, I don't know the speed of the plane, and I don't know the speed of the wind. So let's go ahead and give those our variable names. I'll just use x and y. So I'm going to say, let's let x be the speed of the plane, what this problem calls the air speed, but I'm going to write it as the speed of the plane in still air. If there was no wind, how fast is the plane traveling? And I'll let y be the speed of the wind speed. The letters you've chosen here, remember, are not important. So you could do x and y, a and b. Since they're both rates, you could do rate 1 and rate 2. You could use subscripts. It doesn't make any difference. So now looking at my grid, when I'm filling in on the way there, when the distance was 500, remember it said going there it took 3 hours. It took less time, so that had to be the case where I had a tailwind where I was being moved faster. So my actual rate is going to be my plane speed plus the wind speed as the wind pushes me along. And then that time for that portion of the trip was 3 hours. But on the return trip, I'm getting slowed down because it's taking me longer time. It's 4 hours, and that's because of that wind, that headwind that I'm having to work against. So I have my speed minus the wind speed because the wind slows me down. And this is kind of a simple way then of seeing your equations, because we know that the distance will equal the rate times the time. Distance equals rate times time. So you can drag an equation basically out of this first row of your grid. You can see I have 500 is equal to my rate. Make sure you have parentheses around your rate here because it has two terms, times 3. And then your second row equation would be 500 equals x plus y times 4. So we've created now a system of equations to solve. And you have a couple of options for solving this particular system of equations. Algebraically, we have either substitution or elimination. So one option would be to actually distribute the 3 and the 4. And right now I'd recommend don't write any of this down, but rather just think about which method algebraically makes most sense to you, because there's several ways of solving. So I'm going to mention a few. If you wanted to distribute, then you would have 500 equals 3x plus 3y, and 500 is equal to 4x minus 4y. So this system now is set up for elimination, and you would have to multiply both of your equations in order to eliminate a variable. So let's say you wanted to eliminate the y terms, then we would need 12y. So we'd have to multiply the top equation by 4, remembering that we have to do both sides. And then the bottom equation would have to get multiplied by 3. And I would have chosen y here rather than x because you can see that this term already has one that's negative. And then you would multiply and you would do your elimination. So that's certainly one option. Another option, instead of distributing the 3 and the 4, you could divide both sides by 3 and 4. Because if you take a look at the x plus y and x minus y term here, notice your y's are ready to subtract out if you could just eliminate the multiplication by 3 and the multiplication by 4. So that tends to be my preference. So if I take my top equation and divide both sides by 3, then I'll end up with 500 thirds. And I definitely want to leave that as an exact value. I don't want to put that in my calculator and write down a rounded decimal because I don't want to lose any accuracy in my problem. And then 500 divided by 4 for the second equation. That divides unevenly. Sorry about that. So that's going to be 100. Oh, it did it again. 125 equals x minus y. And now we're ready to go ahead and do our elimination because we see that if we add straight down, the terms with the y's subtract out. Y minus y will end up giving me 0. So we're going to have 500 thirds plus 125 is equal to 2x. If we go ahead and multiply 125 times 3, we want to get a common denominator here, so really we have 500 thirds plus 375 thirds. I'm just adding my fractions. In other words, we have 875 thirds is equal to 2x, and then we'll divide it by 2. But remember, dividing by 2 is really the same thing as multiplying by 1/2. So if we're leaving our answer right now in exact form, we'd have x is equal to 875 divided by 6. And then since this is our final answer, we can go ahead and go to our calculator to get an approximate value, since that doesn't divide unevenly, which would be 145.83. Remember two things at the end of the problem, though. You always want to make sure that you've answered the question and you've included units. So going back to our original work, looking at my variable key here, x was the speed of the plane in still air. And the question asked for both the speed of the plane in still air and the approximate wind speed. So therefore, my units here would be miles per hour. since it's a rate, miles per hour, and this was the speed of the plane in still air. So my plane speed is 145.83 miles an hour. But I also need to get my wind speed, the problem asks for both. So this is where you go back in your work and you hunt for your original equations. So remember, you had your original equation here, 500 equals x plus y times 3. You also had your second equation here. So you can substitute our x value into either of these equations. Or we can be even smarter about it and go down to our simplified form here, because this was equivalent. We had just divided by 3. Or even better, look at the bottom one, because it doesn't have any fractions. And that would probably be my preference. I would go down to my equation of 125 is equal to x minus y, and substitute in my value of 145.83 for x minus y. So then I'm going to subtract 145.83 from both sides, divide by your negative, and we should end up with an answer of 20.83. So the wind speed is about 20.83 miles per hour. And there's our distance equals rate times time problem.